Okay, so we're now ready to learn our last exponential shortcut of the section, and we're now into 4.2, and what we're going to be handling are negative exponents. So something that looks like 3 to the negative 2 power. Again, we run into a problem when we try to use what an exponent means. When I say 3 squared, right, this is telling me to multiply 3 to itself 2 times. So I know what that looks like, right? And we get a 9. Or if I have 4 to the third, right, that's telling me to multiply 4 to itself 4 times. So that actually has some meaning to us. But how do we multiply 3 to itself negative 2 times? Again, that is kind of an odd situation in terms of counting. So we have to figure out how do we account for negative exponents. And it turns out we do something very similar to what we did with the exponent of 0. So let's just consider a situation like 3 to the 5th divided by 3 to the 7th. And when we take a look at this, there's two ways that we can think about this. We can use our quotient rule, right, because I'm dividing by the same base. So if I use my quotient rule, I keep that base and take the top exponent and subtract the bottom. And so what we end up with is the very expression that we're trying to figure out. So this expression, right, is equal to that exponent. Of course, we could also approach this by using just what it means to be an exponent, right? So we're establishing another path of equality. So what does it mean to be an exponent? Well, 3 to the 5th tells us to multiply 3 to itself 5 times. And 3 to the 7th says that we're multiplying 3 to itself 7 times. And so now we have several dividing out, right? 3 divided by 3 is 1. We got it again, and we got it again, until all that's left upstairs is 1, and we have 3 squared downstairs. And so, again, because of that transitivity property of math, this expression is equal to 3 to the negative 2, and that same expression is equal to 1 over 3 squared. So what that means is that these two are also equal. So the way that we rewrite 3 to the negative 2 is we rewrite that as 1 over 3 squared. It's similar, it's almost like a reciprocal, right? Because this is technically over 1. So we're basically writing it as a reciprocal, but the good news for us is the negative exponent now becomes a positive. So 3 to the negative 2 essentially becomes 1/9. 4 to the negative 3, well, if we follow this rule, right, we're going to kind of flip it over and raise it to a positive power. And we end up with 1 over 64. So that's essentially how we establish negative exponents. So the rule essentially is if I have a and I raise it to the negative n power, then we essentially flip it over and write it to a positive power. Again, because of the way we establish this, the one number that our base cannot be equal to is 0, because we don't want any divisions by 0. So that's kind of an outlier. It was also kind of a crazy case when we considered exponents of 0, but that's how we essentially handle them. One other item is, let's imagine we're already dealing, let's say we have the number 5, and it was already being divided by 3 to the negative 2. So what happens if the negative exponent is already in the bottom? All right, so if we follow suit, we're going to flip it up, but here's the math. Another way to write this is 5 divided by 3 to the negative 2, and then this is 5 divided by 1 over 3 squared, right? And then, of course, division, this is 5 times 3 squared over 1, right? So we divide by multiplying by a reciprocal. So we end up getting 5 times 3 squared. And so essentially, the reciprocal, if we already have the exponent down in the bottom, then we can basically flip it up, because notice all this is occurring up in the numerator now. I think if we continued on, that'd be 45. So looking at something really difficult, or trying to be difficult, if we had x to the negative 2 and we were dividing it by y to the negative 3, what I would basically do is apply my negative exponent rule to the top and the bottom. So x to the negative 2 would flip down to the bottom to a positive power, and y to the negative 3 would flip up to the numerator with the positive power. And so that's essentially our rule for negative exponents. You basically flip them and write them to a positive power. So now that we've defined what it means to be a negative exponent and how to do with it. We are going to now look at some expressions with negative exponents and how to simplify them. So we'll do that in the next video.